going to look at sum and difference identities. It's important to understand that the sum and difference identities are complex identities that come from the development of two different triangles, such that you're going to try and find the sine of those two specific angles in those two separate triangles. This can be proven with a number of identities utilizing the concept of the unit circle. We're not going to prove those in this video today, given the complexity of them, and it's not necessary for you to know those proofs. Just understand that they are coming from a version of two separate triangles, and we're trying to find the sine of those two angles together. So in this case, these are the identities that we're playing with. Sine of x plus y is equal to this. You have cosine, you have tangent, and then you have the difference identities, sine of x minus y. It's important to recognize that x minus y is all inside of the sine function, just as all three of these all have them inside that particular trig function. In regards to working with these, it requires the understanding that the angle on the inside is what could or might not be able to be modified. So our first example we're going to play with is find the exact value of the cosine of 15 degrees. If we're trying to find the exact value of cosine of 15 degrees, the first logical thought process is, what values on the unit circle do I know? Unfortunately, 15 degrees is not one of the values on the unit circle, but it is the addition or subtraction of two angles on the unit circle that we do know. For instance, I can recognize that the cosine of 15 degrees is the same as the cosine of 45 degrees minus 30 degrees. Knowing this concept, again, notice how I'm tearing this apart here to make it two separate angles that I know the values of. If I know the values of cosine of 45 degrees and the cosine of 30, I can't just simply slap them together and subtract this from each other. Again, this is very much like the same as the square root of something, where I have an addition or subtraction on the inside of that square root. I can't just distribute the square root over those two terms. Again, I can't distribute the cosine over these two angles. There is a set of rules for me manipulating the inside with the outside of a cosine function. This is the start of those rules. So we're using the cosine difference formula, that's this one right here, and my x is going to register as 45 degrees, and my y is going to register as 30 degrees. I'm going to go ahead and replace all of those values appropriately. So I'm going to have the cosine of 45 degrees times the cosine of 30 degrees plus the sine of 45 degrees and the sine of 30 degrees. One thing I want to make note here is that the cosine of x minus y alternates the sign to have a plus sign over here. The cosine of plus changes to a minus. You'll also notice that the cosine functions are together and first in the cosine identity, and the sine functions are second after that, again, sign change. So with the cosine, the sign alternates. With the sine, you'll notice that the symbols stay the same, the plus and the plus, but the trig function alternates. So the sine of x plus y has sine and cosine, and then cosine and sine, alternating in that particular order. Again, sine of the first angle times cosine of the second angle, plus cosine of the first angle times sine of the second angle. So once I've got that dealt with, again, there's a way to memorize these identities. Then all I have to do is evaluate each one of these. I know that the cosine of 45 degrees is radical 2 over 2. I'm going to do that same thing with the sine of 45 degrees is radical 2 over 2. That is going to be replacing this whole thing right here. I'm going to multiply that by the cosine of 30 degrees, and I'm going to multiply this one by the sine of 30 degrees. We just have to remember which one it is based on the unit circle. Again, real quick, that's the 30-degree measure mark. I know my cosine is 1, so my cosine will be radical 3 over 2, and that's going to help me remember that if my cosine is radical 3 over 2, my sine is 1/2. Now all I have to do is simply multiply all this stuff together and simplify, and I will get the exact value. Now radical times radical, I can multiply their insides, giving me the square root of 6 divided by 4 plus the square root of 2 divided by 4, which if we want to simplify that any further, it's radical 6 plus radical 2 divided by 4. We have to remember that I can't divide the inside of a radical by something that's outside the radical unless I simplify the radical and move the information outside first. So this right here, the square root of 6 plus the square root of 2 divided by 4 is the answer to that particular problem. Let's look at one more other example that might be a little bit closer to home. The cosine of 70 degrees cosine of 40 degrees plus the sine of 70 degrees, sine of 40 degrees. So again, the example is find the exact value of this. Now, you'll notice once again that cosine of 70 and cosine of 40 are two values that are not on the unit circle. They're not values that we actually know the exact numbers of. So what we're going to have to do is we're going to have to match this information up to my identities on the paper. And uniquely enough, we'll end up looking at the exact same identity right here. I'll notice that the sine and cosine are different. I have cosine, cosine. So it can't be the sine identity in any way. We can look at the cosine identity and notice that this is a plus sign and this is a minus sign. So it can't be that one. So it's got to be this one over here where cosine, cosine plus sine, sine. With the identity selected, I'm going to go ahead and try and figure out what x and y are. It looks like x is supposed to be 70 because that comes first, and my y is supposed to be 40 because that comes second. So in this case, I'm going to have the cosine of 70 degrees minus 40 degrees, which is equal to, now I can simplify the inside of an identity, or inside of a trig function. I can simplify this together. Once this identity is recognized, can smash together to be this, then this right here is the cosine of 30 degrees. And we know the cosine of 30 degrees be radical 3 over 2. Again, all of the examples that we're working with here are some semblance of manipulating what we have to make it something that we can actually work with. Again, we can't work with finding the exact value of this. We can't work with finding the exact value of this. So we're going to use an identity in our best way to get to something that we can find the value of. And our goal is, again, to eliminate the trig functions as a whole. So I'm going to have sine of 5 pi over 12 as one more. Find the exact value of this particular case. Well, my first recognition of this is pi over 12 is not a nice value on the unit circle. So it's not going to be something that I can work with efficiently. What, however, if I just start playing with the numbers of 5 pi over 12 in order to get to something that makes sense? Well, first of all, maybe I can do some form of common denominator. Given that 12 is here, I can tear this apart to make it pi over 3 and pi over 4. The other option is I can just start tearing numbers apart until I can manipulate this in such a way so that I can get to something like that. So for instance, one thing that I could do is I could change this to be the sine of pi over 12 plus 4 pi over 12. Now, you might ask, why would I pick those two numbers? Well, this right here can simplify down to make it pi over 3. This one can't simplify down, so that might be a little bit of a hiccup for us. Maybe this one's not the best one to go with. Again, these are just options of what we could think of. Maybe this doesn't work. Maybe another option I could try and pick is the sine of, let's do 2 pi over 12. That'll get me down to a pi over 6, which I know is on the unit circle. And I could do 3 pi over 12, which then get me down to a pi over 4. So this might actually work to our advantage, remembering that if I smash these two numbers together, I do get back to this. There are other ways to go about trying to find the values that are going to work best for this, but we're going to go ahead and just go with the first one that we can find that makes the most sense. It'll look like then that I'm going to use the sine of x plus y, such that x is this pi over 6, what it simplifies down to, and that my y is pi over 4. So I'm going to rewrite that one more time. Sine of pi over 6 plus pi over 4, keeping in mind that I can't just, again, distribute trig functions over addition or subtraction. That is not a algebraic thing that I can do. So I'm going to come back to here. This piece here is going to be equal to then, utilizing this identity right here at the bottom of the screen, sine of x. So I have the sine of pi over 6 times my cosine of y, so the cosine of pi over 4. Remembering that sine has the addition here, it's going to keep the addition the same. What's going to change is the alternating in the trig functions. So I'm going to have next the cosine of pi over 6 times the sine of pi over 4. Now that I have all that, I just go back to the unit circle, evaluate those individual details, and evaluate what they actually are by simplifying. I know that pi over 4 for both sine and cosine are radical 2 over 2. I know that the cosine of pi over 6 is the same thing as the cosine of 30 degrees. The cosine of 30 degrees was radical 3 over 2. And the sine of pi over 6 is going to be, again, the sine of 30 degrees, which is just 1/2. So we end up getting the exact same answer as we did previously, such that it's radical 2 over 4 plus radical 6 over 4, but that's going to be condensed down to radical 6 plus radical 2 all over 4, which we can't simplify any further. Again, these are how you can evaluate certain trigonometric um, expressions based on utilizing the sum and difference identities.